one of the most common way to join parts together is to use threaded fasteners, as we have here. You can find threaded fasteners everywhere, in your cell phone, in the car, in the bridge, or on the airplane. Everywhere we use threaded fasteners. And what we want to achieve when we join parts together is the clamp load. But the clamp load is extremely difficult to measure. So instead we use torque to estimate the clamp load. And if the clamp load is too low, the parts will fall apart, and if it's too high, there's a risk of the parts or the joint or the thread to get damaged. So it's really important to know what torque you apply, so you don't have too little torque or too much torque. And what we discuss when we're discussing that is accuracy. So in front of me I have 4 different tools, and they can all achieve 150 to 200 Newton meters or 110 to 150 foot-pounds, but they do it differently. So these 2 tools, it's an impact wrench and a pulse tool. They are fast and reaction-free, but maybe not as accurate. These 2 tools are continuous driven nut runners. They are not as fast, they are not reaction-free, but they have very good accuracy level. So let's say you want to do a 200 Newton meter or 150 foot-pounds tightening on a joint. What tool should you choose? If you're just going to do loosening or pre-tightening, an impact wrench is perfect because it's really fast and reaction-free. If you need some kind of accuracy, you should step up to a pulse tool that can shut off like this ergo pulse tool. If accuracy is important, then you should go with direct driven nut runners. So let's run some tools so we can see the difference between a reaction-free tool and a tool that isn't reaction-free. First, we need the socket. And then, of course, protective equipment. And to run these tools, you need air. And remember, good airline installation with the right hoses and the good couplings. That's how the pulse tool works. So let's try the direct driven tool, the LTP. And this one needs a reaction bar and a reaction point to handle the reaction force. So this tightening went really fast because this is a hard joint, and hard joints, it takes less time to tighten a hard joint, and that goes for any of these tools. This is a soft joint, and that one takes longer time. So when selecting a tool for your application, it's a matter of knowing the torque and then finding a balance between accuracy and speed for your specific application.